Welcome back to Math. This is Section 11, Graphing Linear Equations. We'll talk about graphing points, graphing lines, slope, the slope-intercept form, and the point-slope form. First we'll start by graphing some points, and let's start by looking at the structure of the graph. There's the familiar number line here. We call it the x-axis, or the horizontal line. It's a regular number line. Numbers increase as they go from left to right. 0 is in the middle. That means the positive numbers are here, negative numbers are there. And then there's a second number line added to that as a vertical line. We call this the y-axis. The numbers increase as you go from the bottom up. So these are the positive numbers, and these are the negative numbers. Now we have this kind of plane of space that we're talking about, and then we can locate points on that plane by telling it where it is, by where it lines up with the x-axis and where it lines up with the y-axis. So I'm looking at this point first, point A we call it, and it's called 2, 4. That's its location. It lines up with the 2 on the x-axis line, right? This is the x-axis, here's 2. It lines up with that 2. And it lines up with 4 on the y-axis line. This is the y-axis, here's 4 on the y-axis, and it lines up there. So its coordinates, its location, we call 2, 4. Those coordinates are considered to be an ordered pair. That's because it's a pair of numbers, and the coordinates are listed in order, x and then y, just like in the alphabet. So when you look at the coordinates, you always know that 2 is its x value, 4 is its y value. You can kind of think of this as a city grid. Some cities that have numbered streets and maybe lettered streets, and you say, hey, I'm standing at the corner of 2nd and D Street. Well, this is the location of point A. It's the intersection of 2 and 4. Here's another point in this plane, this grid, if you will. It's labeled point B, and its coordinates are 0, 0. That means it's where x is 0 and y is 0. It's kind of a special point because it's called the origin. It's the very center of this graph. Over here we've got point C. It's labeled with the coordinates -5 and -2. So its x value is -5. That means on the x-axis we go down to -5, and that's what it lines up with. And it lines up with the y-axis at -2. So it's at the intersection, the grid line, of -5 and -2. Now let's talk about graphing lines, and we'll start with a very basic horizontal line. Unlike points that just have coordinates that actually indicate a single point, lines are all the points connected in a straight line. And so instead of having coordinates, they have an equation that tells us about their properties. This particular line is the line that we call y equals -3. That's because on the y-axis, we've found the place where y equals -3, and that extends all the way, and in fact the arrows mean that it can go forever and ever to the left and the right. We say it has a y-intercept of -3. That's because it intercepts, or it crosses the y-axis at -3. And here's an example of a vertical line. This line here intercepts or crosses the x-axis at -4. And then it goes forever and ever up and down all the places where x is -4. So we say that its equation is x equals -4. Now let's talk about slope. Slope tells us two things about a line. It tells us how steep it is, and it also tells us whether it slopes in what we call a positive or a negative direction. A line with a fairly large slope number is steep. The smaller the slope number, the less steep the line is. Also, if it has a positive slope, it slants in this direction. Think of it kind of as a forward slash on your keyboard. If it has a negative slope, it slants in that direction. Think of it as a backslash on your keyboard. The definition of slope is rise over run. So if you know 2 points on a line, you can figure out what its slope is. Let's look at this point first. It's the intersection where x equals 0 and y equals 1. We'll call that point number 1. And then look at this line. It's where x equals 1 and y equals 3. Let's call that point number 2. If we look at the rise over run, starting at point 1 and going to 2, that means we rise 2 grid lines and we run 1. Oops. Simplifying that, we get 2. So this line has a slope of 2. It doesn't matter which direction you go, so I could also go from point 2 to point 1 and I'd get the same slope. So if I start here, this actually has a negative rise to get down here. We would say that that is going down 2 grid lines to get from here to here, down 2 grid lines. And it has a backwards run. We run back 1 grid line to get there. But that's the same slope because 2 divided by 1 is 2. Negative divided by a negative is still a positive result. We can also use this formula. That looks a little complicated, but it's really not. The 1 and the 2 refers to the point number. So if we take this point 1 and point 2, this says that we want to take the y value of point 1, that would be 1, minus the y value of the second point, that's this, and we want to divide that by the x value of point 1. This is point 1, it has an x value of 0, minus the x value of point 2. Okay, 1 minus 3 is negative 2. 0 minus 1 is negative 1. That's the same as doing this process, isn't it? There's 2 special kinds of slopes that we should talk about. Again, remember, slope is rise over run. If you're talking about a horizontal line, that just doesn't have any rise, ever. And it has a run of, well, infinite, really. I can use the sign for infinity. But basically, if a line is horizontal, we say that it has a slope equal to 0. What about the slope of a vertical line? Again, rise over run is our formula. This has infinite rise, but it has no run. And in math, we can't divide by 0, so we call that undefined slope. A vertical line has undefined slope. Now let's talk about graphing lines using something called the slope-intercept form. That may be familiar to you, the y equals mx plus b equation. And that just means 2 things, that we know the slope and we know the intercept. Let's be a little more specific. We call slope m in this formula, and we call the intercept b. And specifically, it's the y-intercept. That means where it crosses the y-axis. We can figure that out about this line, and if we do, we'll know the equation of the line. Alright, the slope we're going to call m, and that's rise over run. And if we look at these 2 points, again, any 2 points, you can find this slope. So from here to here, we rise 1, 2, 3, but we run backwards negative 1. so that we say that it has a -3 slope. And where does it cross the y-axis? It crosses here at -2. We call that the y-intercept, and we label it as b in this equation. So when we say y equals mx plus b, we substitute our slope for m, and our b is -2. Plus a -2 is really -2. So this line has the equation of y equals -3x minus 2. Every point on this line satisfies the equation y equals -3x minus 2. That means it makes it true. So for example, we could pick a point on this line. Let's pick this point way down here. It's the point 1, -5. If we substitute those numbers in for y and x, we'll get a true statement. So its y value is -5 equals -3 times its x value, that's 1, minus 2. -5 equals -3 minus 2. -5 equals -5. So remember, if you know the slope and the intercept, you can find the equation of a line. And if you know these two things, the slope and the y-intercept, you can draw the line. If you start at the y-intercept, -2, and you find another point that is a -3 slope away, that's down 3 over 1, or up 3 back 1, you've got 3 points. You just connect those points, and you've got the line. We'll do another example of the slope-intercept form, but this time we're going to start with an equation that doesn't look like it's in the standard format. But we can get it in the standard format, and then we can graph that line. So we want to get y all by itself on this side of the equation. So what we'll do is we'll move the x's over to the other side. We get 3y equals -2x plus 6. And then we'll divide each side by 3. Remember, we have to divide both terms by 3. And we get y equals -2/3 x plus 2. That's what's graphed here. If you just find the y-intercept of 2, that's here, and then you go down 2 over 3, there's another point, and connect the dots, there's the line. That means that, again, all the points on this line make this true. So we can take this point here, which is the point 3, 0. If we put that into this equation, it will also give us true. So if the y is 0, the x we're going to substitute 3 plus 2. 0 equals -2 plus 2. 0 equals 0. There's another way to find the equation of a line, and that's when you know the point and the slope, so we call it the point-slope form. So let's find a point on this line, and we can use this one. This is where x equals 3 and where y equals 2. So it's the location 3, 2. And then we need another point to find slope. So this point is 4, 4. The slope is rise over run. From here to here we rise 2 and we run 1. Here's our equation for the point-slope form. Using this equation, we can substitute in what we know and get the equation of this line. We'll use this point, so the y value is 2, the slope we found is 2, its x is 3. Now let's do the math here and clean this up a little bit. 2x minus 6, and we add 2 to both sides. So this line has the equation of y equals 2x minus 4. Try the examples in the practice problems. So you'll get a lot more experience, and then we'll go over them together.